Welcome back. This is input-output programming in C#. The following will be our objectives. Number 1. What are streams and why do we need them? Why do we need buffered streams? Text input or output, primitive data type I/O, and object serialization. We look at each one of them in greater detail. Okay, let's briefly talk about input-output devices. Input and output devices are external to your environment. That means they're external to your computer's processor. Input devices are, for example, the keyboard and the mouse, and output devices could be your screen, printer, and the file system. So, your processor interacts with these input-output devices through specialized software called device drivers. Different device drivers behave differently in different platforms and systems. For example, the mouse interface or the device driver for a Windows operating system is different than the mouse interface or the device driver for the Linux systems. Do we as programmers need to worry about all these finer details of how the various input-output devices are connected by means of device driver to our computer's processor? No, they are too complicated for us to start worrying about them and not focus on the problem at hand. That is why the C# language gives us a beautiful abstraction called streams. What is a stream? A stream is an abstraction representing an input or an output device. And what do you mean by abstraction? An abstraction is like a black box. What is inside the black box? We do not really know. It is always debatable what could be inside, and as they say, it is best left to itself. Similarly, C# streams is an abstraction. The C# language handles all the fine details of the various input-output devices, freeing us, the programmer, to concentrate on the real problem-solving application. Since we have input or output devices, we have input streams and output streams. C# always encourages us to program in terms of streams. The programs we write are compiled to intermediate language, which is then executed with a common language runtime. This common language runtime takes care of the fine details of actually interacting with the hardware using the respective native device drivers. We interact with the streams, and the CLR internally interacts with the device drivers and gives us the required input-output functionality in our programs. Let us start with the file system. The file system is the heart of the input-output environment. We know the data is always represented as bits and bytes. It is this file system that organizes the data, provides a name and a storage and retrieval mechanism, which is based on the file name, and provides actual meaning for the data. Without the file system, our data is just bits and bytes. Right? So, files and directories are abstracted by classes in the .NET framework. To handle files, we have the file class, and to handle directories and the associated functionality, we have the directory class. Please note, all I/O classes that are provided with the .NET framework are available in the system.io namespace. To perform I/O operations, we have to include system.io namespace using the using directive. Working with directories. The directory class exposes static methods for creating, moving, and exploring directories. Please note, all the methods of the directory class are static. We have a get directory, get directories, create directory, get logical drives, get files, get parent, and even a move method which moves directory and its contents to a different specified path. The file class is used for file operations such as creating, copying, moving, deleting, and appending to files. We have the create method, the copy method, the delete method, then the open read and the open write, which gives us a stream on the file for reading and writing, create text, append text, to write text to a new file or an existing file. So let's look at file streams. To read a file, you need an input stream, and write to a file, you need an output stream. So how do we get the input stream and output stream on the file? The openRead and the openWrite methods on the file class provide us a stream for reading and writing to files. For example, let's say I have a file sample.txt. Now, if I want to get a stream on this file for reading, I would call the openRead method. Similarly, if I want to open a stream on this file for writing, I would call the file.openWrite method. Okay, so let us look at a simple example of copying a file. Here is a copy file example. First of all, we need two streams, an input stream and output stream. Input stream reads from the source file, the output stream writes to the destination file. Here what we do is we declare a byte array, and we call the byte array as buffer. You could give any name you want. Buffer is just a variable that denotes a byte array. Then on the input stream we do a read. Okay. And the read we pass in a buffer, which is a byte array. The read method reads bytes into the byte array and returns the number of bytes read. It continues to read from the input stream till the bytes read equal to 0. When bytes read equal to 0, it means we have reached the end of the file. And as we read bytes into the byte array, we use the output stream's write method to write it to the underlying file system. So this simple example has a read from the input stream and a write to the output stream. Read reads bytes into a byte array, and write writes the byte array to the underlying file system. The read method, remember, the read method also returns you the number of bytes read. And when the bytes read is equal to 0, it means we have reached the end of the file. Once we are done reading the file and writing to the file system, we close the input stream and then the output stream. Okay. So let's look at a short demo for the copy file. Remember, the source code for the demos is available on the website itseasytolearn.com/.net. Navigate to your input-output programming page, and there towards the end of your tutorial text, you will see the link to download the demo. Okay, so let me bring up Visual Studio. So if you have downloaded the program, the source, it's available on the website, and open it into Visual Studio, you would see something like this. You will have program.cs and a class called IOUtils.cs. This is the class we're going to focus on for now. Okay, open up IOUtils.cs and you would see a method called copy file. Okay, the copy file method takes two parameters, a from, which is a source, and the to, which is the destination. Okay, so what we do is, from the source we do openRead to get an input stream, and to the destination we use an openWrite to get a stream to write to the destination. Okay, so input stream and output stream using the file openRead, openWrite methods. Okay. Then on the input stream we do a read and we pass in a byte array. The read method returns us a integer value which tells us how many bytes are read. So as we read bytes from the input stream into the byte array, we write them to the output stream using the write method. We continue to do this reading from the file until bytes read equal to 0. When bytes read equal to 0, it means it has reached the end of the file. Right? A very simple program to actually copy a file from from a source to a destination, right? Okay, so if you look here in this example, we have a try and a catch block. Okay, so try catch block is always used when using resources that are external to the program. For example, the stream, input stream and output stream are handles to the actual file in the file system, right? They are an external resource. Whenever we deal with external resources in our code, it is generally and always a good practice to enclose the external resource usage inside a try and a catch block. You have a try and then there's a catch, okay, and then there is a finally block. So in the finally block, what we do is whatever resources we have used, which is the input stream and the output stream, okay, these actually are an external resource that has been used in the program. They have to be released. Okay, the release happens through the close method on the input stream and the close method on the output stream. We want to make sure that the streams are closed properly. We do not want to have the streams lying open after a program terminates, right? So in general, it's always a good practice to close the streams in IO programming in the finally block. Okay, so going forward, the recommendation for you is to always use a try, catch and a finally block, and in the finally block always close the streams. Okay, so let's go to program.cs and run this method. Okay, I have commented out the rest of the demo and use only the copy files. So you could do the same thing so that we go through the examples one by one. Okay, so in my main program, what I'm doing is I'm going to copy a file called sample.txt in the path c:/io. I'm going to copy it into c:/io sample copy.txt. First of all, for this program to execute, the file sample.txt has to exist. If the file does not exist, we will get an error. Okay. Currently what we have done is, so let me go to my local folder. I'm in the C:, okay, and I don't have IO. So let me create a folder called IO. New folder. I call it IO. Okay. Then I go to this folder and say new text document, and then give the name as sample. Okay, now I open sample.txt. It opens in TextPad for me. It will open very well in Notepad for you. So depending on your editor, your favorite editor, mine happens to be TextPad for now. I enter some text, any text. Okay, so just 3 lines I think should be enough for now. Let's save this file. So the file is saved in c:/io sample.txt. Okay, let me close this file. Now go back to this c:/io folder and I have sample.txt. Now my program is going to copy this file sample.txt into sample copy.txt. Okay, and then once I'm done copying, I'm going to display the contents of the file sample copy.txt. Displaying the file, this method, display file method, is equally simple. Let's go back to IOUtils class to look at the display file method. The display file method takes in an input parameter, which is the file name, the path to the complete file. Here we do an open read to get input stream on the file, and then we do a read again, read the data into a buffer, which is a byte array, and as we read the bytes into the byte array, we write it to the console. In the previous example, we wrote it to the output stream. Here, we don't write it to the output stream, we write it to the console. Okay, since the data in the byte array is a byte, we convert it into a char so that it prints properly on the screen. Okay. Very simple program. Let's run this and look at the output. Okay, so here we are. So the file sample copy was created, and then the contents of sample copy is displayed as hello there, welcome to C# IO programming, have a nice day. The same text we entered for the sample.txt. Okay, so this is a very simple program and your very first program to copy a file from a source to a destination. Okay, so let's go back to our learning. Next we move on to buffered streams. We know that every IO operation causes an interrupt on the system. IO operation is an external environment from the computer's processor, right? So whenever an IO request happens on a program, the process that is currently executing has to suspend its execution and hand over control to the operating system. The operating system then reads the data from the location, which is the memory or file, and writes the data to a location depending on the case. For example, so let us say you have written a C# program, and when you compile this program and run it, okay, it is converted into a process. Let's call this process as P1. Okay, in your computer processor for the moment, there are multiple processes running simultaneously. For example, you have a printer attached to your computer, you have a printer process running, you have the display process, you have a process to process keyboard events, the mouse processor to process the mouse clicks. Multiple processes are running in your operating system, right? Every program you write, when it executes, is converted into a process. Okay, now remember we talked about the heap memory. The heap memory is the area of the memory, is generally the RAM, which is addressable by the processes. The processes can access memory in the heap. Okay. Now what happens is, whenever a process is created in the operating system, a specific memory is allocated in the heap for the process. In this example, we look at P1 and P2. P1 has the process memory area M1, and P2 has the memory area M2. Now, a very important rule. Every process can access only the memory which it is allocated to it. For example, if P1 is allocated memory M1, P1 cannot access the memory of process P2, which is M2. And if P1 tries to access the memory beyond this addressable memory area, then there is a general fault in the computer and the systemic crash. Okay, so it's always a good practice. I mean, this is something which we don't have to worry about, right? The operating system makes sure your process only accesses the memory which is supposed to access. Okay, so please get this very clear. Every program you write is converted into a process which has a memory allocated to it on the heap. The file system, which is a hard disk, is a separate entity from your heap memory. It is in the file system that the actual file is stored with a file name and a file path. Okay, so let us say your program P1, your process, needs to read a file from the file system. Remember, P1, your process, can access only M1 memory. It cannot access the file system, right? But the file C:/IO sample.txt exists in the file system, not in the heap memory, right? So when you want to do a read, what happens is, you tell the OS, I want the file c:/io sample.txt. Okay, then what operating system does is it halts your program, it suspends your process, and then copies the file, contents of the file c:/io sample.txt into M1. Okay, please get this very clear again. Whenever you do a read on a file, on a stream, what happens is the file exists in the file system. The operating system copies the contents of the file and places into memory area M1, and only then can your program process read from the memory area M1. Okay, so this is called an interrupt. So when an interrupt happens, when a request for external resource or a file system happens, the current program is paused, the current process is paused, and an interrupt is created. The operating system looks at the request. If it's a file read, it copies the file contents from the file system to the heap memory, and then lets your process know that it is ready, that is done, you can read the data. So every read you do causes an interrupt. Okay, so this transfer of control between the process and operating system causes strain on the processor. So if you want to reduce the strain, we need to use buffered streams. So the C# language provides an abstraction in the form of buffered streams. Here data is written to a stream in blocks, not in bytes. Whenever you say read, even though you may specify a size, say 128 or 256, whatever your byte array size is, C# will go ahead and read more than that in memory, in multiples of 512 bytes. 512 bytes is called a block. So when the next read comes, it does not cause an interrupt again, but it reads from the internal memory. Okay. So this way the number of inputs are reduced using buffered streams. Whenever read happens in a buffered stream, a block of data is read ahead, causing the next read to fetch from the internal buffer, not from the OS. When writing to a buffered stream, on output stream you have buffered stream. When you write to it, the data is physically moved to the device. It is written to the internal memory and is returned to the device only when the byte count crosses, say for example, 512 bytes. Even though you may write 10 bytes at a time, or whatever your size may be, only when it reaches a different threshold will be actioned into the file system. Okay, so this is the abstraction, the buffering, which is provided by the buffered streams. So one important point to remember is, when using buffered stream to write to a file system, we write to the file only when it crosses a certain threshold. But we may reach the end of the file before we cross the threshold. So finally, at the end of a program, we need to do a flush to flush the remaining bytes to the underlying output stream. So buffer streams provide an abstraction in the form of minimizing the interrupts on the operating system. They are an optimization on the IO process. So how to use buffered streams? Very simple. You open it, you have input stream and output stream using the file open read and the file open write methods, and then you create a buffered stream from the input stream. You create an output stream, which is a buffer output stream, from the output stream. Simply, what it means is simply wrap the input stream, output stream to a buffered stream, and then we do a read and a write similar to the normal streams. And what happens internally is the data is buffered into the internal memory, minimizing the number of interrupts to the OS. And then remember, when we're done with the program, we need to do a flush. And finally, we close the buffer input stream and the buffer output stream. So one important note here is, when using buffered streams and normal streams, in small files you do not see file sizes you do not see much difference. So internally, even though you use normal streams, C# can always enhance it by using a buffered stream without explicitly stating it. But as programmers, it is always better for us to be explicit and use buffered streams whenever we can. So here is the recommendation: use a buffered streams wherever you can. Okay, let's look at a quick demo again. Okay, let's close the program and then open up Visual Studio. So go to the class IOP2.cs. There is a copy file using buffered streams method, which again copies a file from a source to destination. The only difference is we have input stream and output stream, and then we wrap the input stream and the output stream to a buffered input stream and a buffered output stream. And then we continue to read and write from the buffered streams, and at the end we do a flush. In the final block we close the buffered streams and then the input streams. Display file using buffered streams is again similar to the normal streams, except that on the input stream we create a buffered input stream and we read from the input stream, buffered input stream, and write it to the console. Okay, so let us execute this program. So we are going to use copy file using buffered streams, the same sample.txt. We are going to copy it into a file called sample_buffer.txt, and we are going to list the contents of sample_buffer.txt. Let's run the program and see the output. Okay, here we are. The first output is from the normal streams and the second output is from the buffered streams. Very simple. Let's continue. Working with text files. So for text-based I/O, C# provides stream reader and stream writer. There are two ways to get a stream writer. Remember, for text files, input-output, we use stream reader and stream writer. To get a stream writer, you can either use create text on the file class or append text on the file class. So here what we are going to do is, in this example, we are again going to copy a file from the source to destination, but we are going to use the stream reader and the stream writer. We say file.open text to get the stream reader and the file.create text to get a stream writer. So sample.txt is going to be copied into sample-text.txt. The stream reader, since it is a text file, gives us a method called readLine. The stream writer, since it is text-based I/O, provides us a method called writeLine. So stream reader and stream writer read and write data line by line. This is the major difference between text-based input-output and normal byte-based input-output. The previous examples we saw were byte-based. We read the data into a byte array. Here we are reading the data using the stream reader into a string using the readLine method, and then we're writing the entire string into the underlying file system using the writeLine method. So please note, this is the major difference between byte-based I/O and text I/O. So what does this give us? The stream reader and the stream writer provide an abstraction for the new line character. They provide methods to read and write lines of data from the file. The new line character, the character which comes in when you hit enter, is different in different platforms in languages. Some operating systems use line feed and carriage return, others use only carriage return. Okay, so what does this give us? What does this buy us? Let's say your friend is using Linux operating system. Let's say he creates a file, he or she creates a file, a text file, and sends it across to you, and you want your program to read it. Okay, they may have used carriage return only, or it would have been a combination of line feed and carriage return. We need not worry about that. As long as you use the stream reader and to read from the file, whenever you say read line, it will take care of the dependencies which are built into the file by the native operating system and give you data in a format which your current operating system expects. Okay, so new line abstraction is what is provided by the text files. Okay, let us look at a quick demo for text files. Let's look at IOP2.cs again. There's a copy text file method which takes a from and a to, source and a destination. We use a open text to get the reader and create text to get the writer. Okay, and then we do read line and then we do a write line. And finally, as in all good programs, we close the reader and the writer. Okay, the display file, text file, is again very similar to what we have seen before. It opens the text, it's called open text to get the stream reader, and reads line by line and writes it to the console. So again, it's a good IO program. It has a try, catch, and a finally block. Okay, so let us run this program. Okay, so here we are going to use copy text file from sample.txt to sample-text.txt. Okay, and then we are going to display the file sample-text.txt. Okay, let's save this and run this program. Okay, here we are. The same file sample.txt has been read using a stream reader and written to a file sample-txt.text using the stream writer. So we have sample.txt here. Okay, so let's continue. Now we go to primitive data IO. In order to read and write primitive data to files, we use the binary reader and the binary writer. Primitive data types are the integer, float, double, boolean, string data types. Primitive data types IO is handled specially in C#. Okay, so before we come to that, let's see how to create a binary reader and a binary writer. You can create a binary reader and a binary writer using the file stream. Once you have a binary writer, if you want to write primitive data, we just call the write method and we pass in different primitive data. The write method is overloaded for a float, for a string, for int, for a boolean, etc. To read primitive data, we use the binary reader. Binary reader on existing file stream, on existing stream, we create a binary reader. Okay. And then once and if that stream, if that file which you're reading from the binary reader has data which is written to using the binary writer, we can use the read single, read string, read int, and read boolean to read the respective primitive data types that were written to the file originally using the binary writer. Okay, let us look at the demo. we have a class called appdata.cs. Okay, app data could be your application data. Whenever you write when you write software, every application would have a set of settings, right? So let's assume we have our application has a settings class called appdata, and in this class we have a float, string, int and a bool value. If I want to store the settings into a file, okay, so I would use the stream, get a stream using the open write method and pass it to the binary writer. I would wrap the stream to a binary writer, and on the binary writer we would write the different primitive data types using the write method. As we said, the write method is overloaded and it can take a float, boolean, int, string, whatever value it can. Okay. Now when you want to read the data back, we use a binary reader. Okay. On the same file we open a stream and pass it to the binary reader, and on the binary reader we use read single, read string, read int32, read boolean, etc. to read the primitive values which are written to earlier by the binary writer. Okay. And as in all good programs, we have a try catch finally block. Okay. One important point note here is the binary writer wrote a float, a string, an int and a bool value, right? First is a float, then a string, then it is an int, and then it is bool value. When reading it back, we should read it in the same order. First is a float, and then the string, and then the int, and then the boolean. It should be written in the same order as it is written to. If the order is different, you would have jumbled data, right? So make it a point, binary reader can be used to read only data which is written by a binary writer, and it should be in the same order. It should be written in the same order that it was written to. Okay, so we had a float, string, integer and a boolean. We passed the write method as a float, string, integer and a boolean, and again we should read it in the same order. Okay, let's look at this example now. So okay, so we create a new class, new instance of app data, and then we call the store settings. The store setting methods will write the primitive data to the file called file name is settings.dat and the path c:/io. Okay, so when you call store settings, this is the file name. When you call store settings, it writes the file, it writes the primitive data types to the file settings.dat into the c:/io folder. Okay, and then we do a read settings. Read settings will read the data from the file which is c:/io settings.dat and display it on the console. Okay, so let's run this program. Okay, writing primitive data. About the store settings, we are storing a float, a string, int value and a boolean value, and read in the same order. First is a float, read single, then it is a read string, read int32 and a read boolean. Okay, so and the file was created in c:/io. The file name is called settings.dat file. Okay, this settings.dat file contains the primitive data type IO, primitive data IO. Okay, let's open this file and see. Okay, let's open it in Notepad and see. Okay, This is a binary file. So this is not a text file. Okay. How to read this value? Only the binary reader knows. Right? And the binary reader should read it in the same order that was written into by the binary writer. Okay. So that was primitive IO. Let's go to the object serialization. So we know that everything we program is an object, right? We do real world problem solving and we use modeling. How do you persist state of an object beyond its lifetime? C# provides us with a convenient way to store the state of any object and fetch back the state of the persisted object. For example, let's say we have a student. Okay. We open a stream using the openWrite method, and then we create a binary formatter using new binary formatter, and then there is a method called serialize in the binary formatter which serializes the student data into the stream. Okay. So what happens is the serialize method serializes the student into the stream and stream is closed. When you want to read the data back, we open the stream for reading, okay, using the openRead method. Okay. And remember, in the previous example, the data is stored to a file called student.dat, right, using the serialized method of the binary formatter. Okay. So when you want to deserialize, on the same file, we do a openRead, we get a stream. We have the binary formatter using a new binary formatter, and then we call the deserialize on the stream. It gives us an object. Since in the previous example we wrote a student, okay, we serialize the student, we cast it back to student object, and then we close the string. One important note here is, if you want to serialize an object, then its class must be marked with a serializable attribute. You should mark the student class as a serializable attribute. Let us look at a quick demo. Okay, so here we are, class student. Okay, we have to mark this class as a serializable class. Okay, then we have a method here called serialized data. You pass in the student data and the file path where you want to serialize. You first open the file open the stream for writing. We create a new binary formatter, and then this student is serialized into the stream, and then we close the stream. Okay, just 4 lines of code to store the state of the object. And we want to read back the state of the object. We again open the file for reading. We have binary formatter and we say deserialize. Now in the serialize method we wrote a student, right? So when deserialize, we can safely cast it to a student. Okay, so whatever you wrote in the serialize method, you need to cast it back to that in the deserialize method, and then you close the stream. So very simple, just 4 lines of code to store the state of the object and 4 lines of code to read back the state from the file system. So let's run this program and see. Okay, let's suppose you want to store more than one student, right? So what we do is we can store a list. Remember, we can serialize any object. A list is also an object. So here what we do is we open a binary create a binary formatter. We open a stream for writing, okay, and then we serialize the list of students to the stream, okay, and then we want to deserialize it back. We open the same file for reading. We create a binary formatter, and then we call the deserialize method on the stream. So since we used list of students we serialize list of students, we have to deserialize it back, cast it back into a list of students. So let's run this program to see it in action. Okay, So here we are, serial object data. Okay, I create a new student S1 equal new student, name equal to Harry Potter, age and admission number. Then we just say serialized data. We pass in S1, and the path to serialize it is C:IO student.dat. Okay, right? And then when you want to deserialize it, okay, we say student.deserialize data, and we give the same path. So we get back a student. Alright, when you want to serialize more than one student, we create one more student called S2, which is Ron Weasley, and then we create a list of students S1 and S2. We call serialized students data, and we pass in a list of students, and the file name is students s plural.dat, and then we deserialize it back using the deserialized students data method, and we pass in the originally serialized list of students data. Okay. And then to make sure we read this properly, we print it on the console. Okay, so let's run this method to see it in action. Okay, so we serialized Harry Potter, and then we fetched it in the file system, name is Harry Potter. Okay, now then we serialized two students, okay, Harry and Ron. Then we deserialized them from students.dat, and we got back Harry Potter and Ron Weasley. Okay, so serialization and deserialization, you can serialize any object to the stream using the binary formatter, and you can deserialize any object back from the stream using the binary formatter. Same binary formatter to serialize, same binary formatter to deserialize. Remember, when you deserialize, you have to cast your object back to the desired object type. Since we used in the very first example, we wrote a student object while serialization, we cast it back to student while deserialization. In the second example, we serialize the list of students, right? Students is a list of students. Okay, so when deserializing back from that same file, we have to cast it back to list of students. Okay, so very simple example. Please go to the examples, run them multiple times, and IO programming is very easy. Here is a quick summary of what we have seen so far. We have seen what are streams, why we need them. Stream is an abstraction. Programming IO with actual devices is a complicated subject, right? We application programmers need to focus on problem solving, not worry about the intricate details of how the device hardware interacts with the operating system. No, that is not for us. We are problem solvers, right? Continue to do that. That's what C# tells us. Then why use buffer streams? Because buffer streams provide us some great improvement on the operating system performance. They are an optimization on the interrupts. For text-based IO, why use stream reader and stream writer? Because stream reader and stream writer provide us methods to read data as line by line from a file, the read line and the write line method, and they abstract the new line character. Okay, new line character can be anything, either control feed or control feed and line feed or something new. We need not worry about it. Okay. So that is the abstraction provided by the text-based IO. Similarly, primitive data types IO is handled by the binary reader and the binary writer. Again, primitive data, an int stored in a Linux system can be different than the int stored in a Windows system. The representation of int, we may use on Windows it may be 2 bytes, on Linux it may be 4 bytes. I'm just saying, right? It could be anything. The point is, we application programmers need not worry about how the data is stored in the operating system. We just need to use the binary reader and the binary writer, and very beautifully C# takes care of the storage representation formats for us. Okay, and we saw how to use the binary write method is overloaded, and the binary reader has different methods to read single, to read string, to read int 32, and then to read boolean, right? And we also saw that we should read values from the file that were written to by the binary writer in the same order that they were written. Alright, failure to do so will give us invalid results. And object serialization is all about storing and retrieving object data. We have the binary formatter class, which has method serialize and deserialize. You can serialize any object to a string, and you can deserialize any object from a string. Okay, so and in the whatever we serialize, we have to deserialize back. So we use the cast using the deserialize method. Okay, that's all for now. We have self-evaluation questions. Please refer to the tutorial text for self-evaluation questions and also to the exercises. I hope you enjoy this lesson. We'll see you soon.